This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits. Now that we have our system actually in motion, we're going to take advantage of that by putting our units into action. What this actually equates to is that we're going to be implementing our two system loops that we have. We have our positive loop of if there are enough of a particular type of unit, that unit will increase in number, as well as our negative feedback loop, where as a unit gets hungrier and hungrier, it must eat or it will die, and likewise, if a unit gets eaten, it will die. I really like these two actions in particular because they provide us with a couple of decisions that we have to make in terms of our system. The first is really a question, and both of these are really design questions. The first is, how do we want to order these actions? Do we want to check for the hunger and eating first, or do we want to check for does a unit multiply first? That will have impacts on how our system runs. Likewise, what order of the units do we take? Do we first look at grass and then at rabbits and then wolves? Do we go in reverse? Do we check wolves first at the top of the food chain and then rabbits and then grass? And likewise, do we check multiplication for all the units and then check eating for all the units? Or do we do vice versa and check eating first? All of these things are really design decisions that are going to impact how we list out the actions inside of our loop. I think for the purposes of this particular system, I think it's going to be easiest if we go up the food chain, give the grass a chance to do its thing, then we'll let the rabbits do their thing, and then the wolves do their thing. And likewise, we're going to check for multiplication first, and then for actually whether or not these things will eat or need to eat other things. It'll give us kind of our, give everything the best chance to thrive because you're not going to get eaten before you're able to multiply and things like that. So how we'll do that right now, we'll just kind of write this in commented out pseudocode here. We'll say what we're doing is, first thing we'll do is we'll say grass checks for multiplying, and then grass checks for hunger. Now grass doesn't actually eat, so this is going to be sort of a non-existent thing, but we're going to keep it there because of how we're going to implement this in a moment. Then we're going to have rabbits check for multiplying, rabbits check for hunger, and I'll just copy these two because we're naturally going to do the same thing for wolves as well. Okay, so that's sort of the design process of this. Now the other thing we have to decide with these two actions, multiplying and our hunger actions, is how we implement them. And what I mean by this is we really have two decisions in our system. We can handle everything centrally right within this forest system, or because we have these multiple units that exist within the system, we can sort of delegate out those responsibilities to say, grass, figure out what you need to do on your turn. Rabbits, when you need to check for hunger, you do that in your own class. And I think we're going to take one approach for multiplying and one approach for the hunger, because multiplying really benefits from knowing what's going on throughout the system itself, knowing how many of a unit there are, which our system is tracking. However, for hunger, that's really an internal state for each of the units, checking how hungry they are, and then, seeing what they can eat from there. So we're going to start today with our multiplication system, which is going to be handling our system through really a centralized action. So let's get started by what we're going to do is we're going to create a check for multiply method that can be called, and we can call it individually for each unit type. So we'll say void check for multiply, and we will pass in a unit profile as a parameter, as well as the specific holder, these holder objects we created, so that we can iterate through them, and you'll see why as we implement this. So the first thing we're going to do here is we're going to check, is this the proper time to be multiplying? Remember that we have a multiply frequency property here, which says that we're not going to multiply every single frame, otherwise this would quickly get out of hand. So instead what we're going to do is we're going to double check that the current tick that we're on lines up with the multiply frequency of the particular unit type. We're going to do that by saying here, if number of ticks in session plus 1 and we're adding that 1 there so that we don't, on the very first frame, automatically multiply. We're going to say if that modulo the profile dot multiply frequency, multiply frequency does not equal 0, then we'll return. And the reason for that is basically saying that if we're anywhere that is not exactly equal to the multiply frequency, then we're going to return out. Only when we've hit that specific number. So if the multiply frequency was 5, then we would only be doing this every 5 because the modulo 5 would give us 0, and then from 1, 2, 3, 4, and then 5 gives us 0 again, 6, 7, 8, 9, 10 gives us 0, etc. So we're basically going through and ensuring that we get every fifth or every whatever the multiply frequency value is, that many ticks. From there, though, if we do have it equal to 0, it means we're on the proper window to potentially multiply. And we're going to, first thing we're going to check is how many healthy units there are. Remember, this was this idea that if a unit is hungry, if it can consume and it is too hungry, it's not healthy enough to multiply. So we'll say int healthy units, and we'll start that off at 0. And then we'll say for each transform, we'll just use the letter U in holder. So we're going to iterate through every unit that has been produced and is currently being held in the particular holder that we're working with. We will say if u.getComponent unit dot is healthy, then healthy units will increment by 1. If we jump back over to unit and we look at our is healthy up here, we see that all that is healthy does is says either if you're not a consumer, so like grass, for example, doesn't actually worry about eating anything, so it's just always healthy, or as long as our current hunger is less than our maximum allowed for us to multiply. So if either of those are true, we either don't eat or we're currently not that hungry, then we're considered healthy. So that's why we're then incrementing this by 1 there. So this will give us, once we've iterated through all of the units in this particular holder, we'll know we have 12 healthy rabbits or no healthy wolves, whatever we need. From there, we're going to see how many times do we multiply. Remember, we have this amount that we need, this certain threshold we need, whether that's 6 rabbits or 10 wolves or whatever that number is that we've chosen. And we're going to see how many multiples of that do we have. Is it just, if we have 6 healthy rabbits and we only need 3 to multiply, technically we have 3 and 3, we could multiply twice. Whereas if we need, 7 healthy wolves and we only have 5, then we haven't reached that quota. So what we'll do here is we'll say int times to multiply equals healthy units divided by profile dot parent count required. And so this will basically give us because it's an integer, it'll automatically give us an integer back, but it'll give us the number that we have. So again, if we have 20 healthy units divided by, we need 5 healthy units to reproduce, then we'll have 4 times to multiply. And then we can say, we'll do a double nested loop here. We'll say for, there we go, I is less than times to multiply. And then we'll do a second one in here to say for j less than profile dot child count produced. And so what this is going to say now is every time we multiply, we're going to create this many children. And we'll say here, simply, we'll do that by saying create a unit of type profile. And so that is how we check to multiply. And now we can simply do this every time that we want to check it. So here first, grass will check, and say check for multiply. We will pass in grass profile as well as the grass holder. For rabbits, pass in rabbit profile, rabbit holder, and lastly for wolves, wolf profile, wolf holder. So we're running everything entirely in our system here using the properties we have up here, in particular the holders, to run through and see how many healthy units of that type do we have and to produce more units. This is really that centralized system control though, because it's all happening within the system itself rather than dispersing it out to the other units. If we go back to Unity now, we should see we can hit play here. I'm going to quickly pause this to show that we start off with our starting, here, pull this down a little too, 20, 10, and 5. But if we look at our profiles, we should see here that, for example, grass reproduces every 5, rabbits every 10, and wolves every 20. So let's look at the grass here. We'll keep an eye out on the grass. And if I unpause this, we should see that after about 5 ticks, the grass will multiply. So we'll unpause. 3, 4, 5. There we go. At 5, we're now suddenly increased that number and increase that number again. So every time grass is getting produced. And we've got actually some more rabbits as well in there than we first started with. So everything is producing. Now we're obviously exponentially producing right now, and a big reason for that is that nothing is getting eaten. So what's happening here is simply everything is just producing every opportunity that it has, and so we're getting more and more of everything. And in the grass's case in particular, we're already at almost over 500 grass created, because more and more grass is being created, and therefore more and more grass is being produced every 5 ticks. So in order to kind of do some population control, we're going to need to implement our negative loop as well of eating these things or things getting hungry and dying out. And that's what we're going to do using the dispersed or distributed system control in our next video. In the meantime, thanks for watching, and I'll see you next time.